So in this video, you will conduct a hydroboration reaction with carbon 60. Hydroboration reactions are typically anti-Markovnikov, where the hydrogen adds to the more substituted carbon of the double bond. However, anti-Markovnikov does not matter in this reaction, and I will explain as to why. But first, what you want to do is you want to access the ring fragment icon right here. You select that, you click it again, and you have all these options. You want to select carbon 60, and then you click on your window right here. Okay, so as I mentioned before, the anti-Markovnikov does not matter in this reaction. What actually matters is the radioselectivity of carbon 60. I was able to find an article that mentioned that the C60 bond is preferred over the 56 bond. So basically, it mentioned that the radioselectivity of the C60 bond is preferred versus the 56 bond, and so through impact, we're going to check these. We're going to see the differences of these we're going to see the differences of these reactions with respect to hydroborations happening at the 6,6 bond and at the 5,6 bond. So what you want to do now is you want to right click on this window and access view and click on builder. So what we're going to first modify is we're actually going to work with the 6,6 bond first. So you want to change these atoms into a single bonded. Once you do that, you want to add valency, so you select this icon right here, and then you're going to change one of these hydrogen atoms with a boron. So by doing that, you can do that by selecting this icon right here and click on it again and select boron, close it, and click on the one you want to replace. Close this window, right click on the same window, and now what you want to do is you want to do an impact calculation. So you select calculate impact calculation setup. Your method should be AM1 and restriction Hartree-Fock. Your job type is of course optimization. You submit and you save, and then I'm going to save this as 66 opt. I already have the file, so I'm just going to basically overwrite it. So once the calculation is done, I open the out file. With the out file open, I right click on this window, and then I'm going to select copy, go to edit, copy, and you can actually get rid of this window right here. We don't need it anymore. So you're going to select file, new, create molecule group, and you're going to click on this window, and then you're going to right click on the same window, and you're going to go to file, new, and add to molecule. You're going to get the second window and you just click here. So the second window is going to have your product, and the first window is going to actually have your reactants. So you could close this one if you want to as well. So what you want to do is you want to right click, and to see this better, go to view and center. Now we're going to modify some things. So right click, access view, go to builder, and click on the modify bond. You're going to make a modify between the hydrogen and the boron to make a bond there. Click OK. Then you want to get rid of the carbon and the hydrogen bond, so click on those two, select none, and then you want to get rid of the carbon and the boron bond, so you select those two and you click none. I'm sorry, one thing to do is also you want to stretch out this distance between these two molecules. So select 4, click OK, and that should increase the distance between them two. And then what you want to do is you want to make a double bond. So you select these two molecules, click OK, and there you have it. So what you want to do lastly is clean this, and there you have it. So now you want to do is right click, go to calculate impact calculation, and you're going to run a chain calculation. So you come here and you go to chain, you select this right here, search for all stationary points along the chain, optimize first input geometry, optimize last input geometry, and you want to select here the lowest IR frequency. And so basically this will tell us if we made a transition state, and the overall calculation, chain calculation is basically going to find a pathway that allows this reaction to occur. So I'm going to call this chain 6. Click save. It's going to replace the one I already have. I'm going to say yes and OK. So once the calculation is done, what you want to open is the you want to access the vis file. So you click OK. Having the vis file, you go right click, go to results, and then access chain. And this is basically going to illustrate you the steps to this pathway, as you could see. So what we want out of this calculation is the transition state, and the transition state is this peak right here. So once you find that, and you notice that it's the 6 slide right here, also known as the node 6. So what you want to do is you want to close this, and you know that your transition state is in the 6th node with respect to this reaction. So what you want to do now is you want to right click and you want to copy this. So you go to edit and you go to copy. What you could do is you could actually close this other window over here. Then what you want to do is you want to open a new window. Go to new, create molecule group, and then just click on that. So once you do this, you could then right click and do an impact calculation, and you could this is going to be an IRC calculation. So it's going to be a forward. Your step size is going to be 0.01, and AM1 and restriction heart rate are still selected. So you're going to submit, and you're going to save, and you're going to call this IRCF6, and it's a 6 because I'm referring to the node 6. And I already know it. Yes, already. So I click yes and OK. What you want to select from here is the art file. Selecting the art file, you click OK, and here's your reaction. This is the actual reaction path to this hydroboration reaction. So you could click here on this movie, and you see it bonding to the 6-6 bond here. And you could also right click, go to results, and you'll see the IRC path of this. So you will repeat the same steps for the 5-6 bond, except you're going to do some differences. So what you want to do is, let me close all the following windows. What you want to do is, you want to open a file, you're going to create a new molecule group, and then you're going to select here, select the bulky ball like I've demonstrated before. So the 5-6 bond is actually right here, and the only way to get that is through resonance, where you would actually have this shift of these double bonds to different positions, and one of the positions will be right here, and the other one would be right here. But the one you want to select will actually be right here. So what you want to do is you want to right click here, go to view, access builder, and we're going to change some bonds. So what you're going to do is you're going to select these two right here, and you're going to make them into a double bond. And then what you're going to do is you're going to select these other two atoms right here, and you select single bond, and you're going to select these two right here, select single bond, and then you're going to select this right here, make that a double bond. You're going to select right here, make that a single bond, and then you select right here, make that a single bond. So by doing just those changes to this molecule, you're actually gonna have, well, when you optimize the molecule, you're actually gonna be changing these double bonds. So what you want to do now is add valency, with respect to those two positions. And you're gonna actually change this bond right here to a single bond. I'm gonna select the boron molecule, click twice here, select boron, and then you're gonna replace that atom right there. And then so then what you want to do is you want to actually close this, and then you're gonna go to select calculate, impact calculation setup. You're gonna do the AM1 and restriction hardship fog automation. So you're gonna save this. And you're gonna call this the 5.6 opt. You're gonna click OK. So once that calculation is done, you're gonna open your AL file, and here you have your 5.6 reaction. So what you want to do now is you want to repeat the same steps and eventually end up with the IRC of this molecule. And you could actually compare from here already. You could right click and you can see the summary of this reaction. You can see here that the heat formation was 974, and when comparing it to the heat formation of our 6.6 molecule, I'm gonna look for the AL file of the optimization file 6.6. I open that. So this one is with respect to this molecule right here, and this is our other molecule. So just so you can see, I'm gonna right click, access results, and go to summary. And you can see here that the heat formation values are different. E66 has a heat formation of 956, while the heat formation of the 5.6 is 974. It's a bit, higher. You could also see differences with respect to the core repulsions. You could also see differences in the electronic energy, and that's it. These are the differences you could find with respect to the 6.6 and the 5.6.